class will be basically divided into few sections. Okay, so as I said that in today's class we'll be learning about the touchscreen technology, as well as we'll be learning that how to calculate the pixels per inch in each and every devices that we have. Like you name the technology like LCD, IPS, or any kind of display with any kind of resolution. What is the basic step to calculate the number of PPI? That will be able to understand in today's class. Okay, so first of all, what we'll do is we'll begin with a video which will be of 10-minute length. And the entire length of the video will be of 10 minutes. So we'll be playing that video, and we will try to understand that how a touchscreen works, or how the technology of touchscreen works, with the help of that video. Later, after completing that video, what we'll do is we will be going through that mathematical way by which we'll be able to calculate the number of PPI, or the pixel per inches, in a touchscreen device or any kind of screen with X and Y resolution. Okay, so students, in case if you are ready, if you are ready to watch that video, please type Y in the chat box. Please be ready with your earphones or whatever you have, okay, so that you can understand it in a proper way.
It's hard to imagine that just a couple of decades ago, touchscreens still sounded like something you'd only see in a sci-fi movie. And look where we are now. They're pretty much everywhere. So that got me to thinking, how do touchscreens work anyway? More on that later, but first, I'll tell you what surprised me the most. Get this, touchscreens already appeared way back in the 60s. In 1965, E.A. Johnson created the very first finger-driven screen. Granted, it could process just one touch at a time, so still a long way to the multi-touch displays of today. And it either registered this touch or not. Pretty basic, but come on, it was the 60s after all. Besides, even such a simple technology, by today's standards of course, had its takers. For example, the idea had been used by British air traffic controllers till the late 90s. But even though Johnson was the first to create touchscreen technology, these displays hadn't gained popularity till the 1970s, when the resistive touchscreen was accidentally invented. The who biddy whata be and what was created accidentally? I'll get into the different kinds of displays here shortly, bear with me. But this incidental ingenuity happened in the US, where a research team headed by Dr. G. Samuel Hurst was studying atomic physics at the University of Kentucky. In their experiments, the scientists needed to use some equipment that was so overworked that it was only available at night. You can imagine how much that inconvenience was slowing down their progress. It was then when Dr. Hurst and his colleagues thought of using some electrically conductive paper in their research. By using this idea, they eventually created the first computer touchscreen ever. Now the researchers could do tasks that had previously taken days to finish within a matter of hours. Further developing on that new technology, scientists at the University of Toronto invented the first multi-touch display in the 1980s. As for the very first touchscreen cell phones, they came out a little later in the 90s. Now, all this time, touchscreens were always pretty hit or miss. That is, don't imagine the really cool super fast finger movements you do on your phone these days. But the technology was getting better and better. So you can thank these old dinosaur versions for the incredible screen you have today. So, back to the question at hand. What's the magic behind touchscreens we know and love today? If you thought that just one technology stands behind this swipeable phenomenon of our time, think again. In fact, there are more than half a dozen approaches to make touchscreens work. The two you might be most familiar with are the resistive and capacitive displays. Resistive touchscreens are the simplest and most commonly used. If you've ever withdrawn cash from an ATM, you know what they are. What about that part-time job you had as a cashier when you were a teen, or each time you sign your name, or just draw a smiley face when you're checking out at the grocery store? Those point-of-sale screens are also this type. The technology is simple. You press on the screen hard enough and it bends and resists your touch, hence the name. But what happens next? The thing is that a resistive screen consists of two layers that can conduct electricity. But while one of these layers is resistive, the other is conductive. And between them, there are these things called spacers. They're tiny dots that separate the layers until you touch the screen. So, to put it simply, an electrical current is constantly running through the two layers. Then, all of a sudden, your finger hits the screen. The two layers get squished together and the electric current changes. The device software feels a change in this particular spot and does its work, meaning that it fulfills the function that corresponds with that place. You click on the $20 button instead of the $50 button, and the ATM spits out your $20. On the one hand, resistive touchscreens are reliable and durable, but on the downside, they're pretty hard to read due to their multiple layers. And the more light falls on the display, the harder it is to make out what's written there. Ever tried to withdraw cash at an outdoor ATM on a sunny day? Forget about it! On top of that, you can't zoom in to see the little print more clearly. Unfortunately, resistive screens can handle only one touch at a time. So, do you have this type of screen on your smartphone? Thank goodness no. What you use to scroll through social media, or my personal favorite, hitting snooze over and over again, is a capacitive screen. And its main difference from the resistive kind is that this screen doesn't want you to poke it with your finger. Oh no! Instead, the capacitive screen changes the electrical current when it comes into contact with anything that holds an electrical charge. And by that, I mean you, or rather your skin. Just like everything else, it consists of atoms that are negatively and positively charged. Capacitive touchscreens are made from either indium tin oxide or copper. Both of these materials keep electrical charges in super tiny wires, with each of them way thinner than a human hair. But here's where it gets a bit more complicated. The thing is, there are two different kinds of capacitive touchscreens: projective and surface. Projective displays use a tight grid of special sensor chips. As for surface displays, they use itsy-bitsy sensors in the corners as well as a paper-thin film evenly distributed over the screen. But whichever type of capacitive screen you use, as soon as your finger hits the display, it transfers a teeny electrical charge back to your finger. As a result, you have a complete circuit, which leads to a voltage drop in a particular place on the screen. Voila! The software analyzes the location of this voltage drop and follows your command. Yes, I'd like to snooze for 5 more minutes, thank you kindly. So, ever wondered why your cell phone won't respond when you're wearing gloves? The problem is that clothes don't conduct electricity, unless you have special gloves fitted with conductive threads, of course. And what about when your fingers are kind of wet? That causes problems with your touchscreen for the opposite reason. Water conducts electricity, so the screen can't tell where your finger is touching, because the water is also grabbing some of that electric charge. But like I mentioned earlier, even though these two touchscreen types are the most popular, they aren't the only ones that exist today. Hey, ever heard of an infrared touchscreen? Whoa, fancy! Remember those action movies where the main character has to steal something from a highly protected room secured by a grid of infrared rays? Touch one of those rays and you set the alarm off. Well, similar technology is used in infrared touchscreens. Their displays shine infrared light in front of the screen, kind of like an invisible spider web. As soon as you touch the display, your mission's failed. Just kidding. You'll just interrupt a couple of the infrared rays, and it'll set up a reaction. By analyzing which rays you've interrupted, a microchip in the screen will then know your intentions. Most e-readers have screens like that, by the way. Here's one that sounds super fancy: Surface Acoustic Wave Touchscreens. To detect your finger, this technology uses sound, not light. Ah, fancy functions for its fancy name. The screen creates ultrasonic sound waves at its edges, and they get reflected back and forth all over its surface. As soon as you touch the screen, You not only disturb the sound beams, but also absorb their energy. That's how the built-in microchip controller understands where you've touched the screen. Don't even bother holding this type of screen up to your ear. These ultrasonic sounds are too high-pitched for your human ear to hear. If you don't have human ears, well, that's another issue. One more type of touchscreens, called near-field imaging, is so tough that it's suitable for the most challenging environments. That's why it's widely used in the military. When you move your finger closer to the screen, you change the glass screen's electric field. As a result, it immediately recognizes your touch. Such technology allows you to control the screen with the help of a pen, stylus, and even while wearing gloves. Oh, by the way, most people don't realize just how widely used touchscreens are. In fact, nowadays, it's hard to find a field that doesn't make use of them. Airplanes, stores, banks, schools and universities, hospitals, you name it. Also these days, with the help of special devices, you can turn literally any surface, be it your desk, a wall, or even your skin, into a touchscreen.
Okay, students, I hope as of now you have an idea like how touchscreen devices work. Please acknowledge in case if you have learned something from the video, like how touchscreen works and what are the different type of touchscreen devices that are available in the market. And the reason why the touchscreen devices don't work when we are wearing gloves or something like that. Okay, so this was a small video where we have learned like what are the different type of touchscreen devices available and how they work and what was the inception of the touchscreen devices, like how they got invented and where we are as of now regarding with respect to the touchscreen technology. So now what we'll do is now we'll be learning how to calculate the pixel per inch or the PPIs of any screens or any devices or any display. Okay, like what is the method of calculating the number of pixel per inch in any display that we have as of now. Okay, so I hope you know that each and every display that we use have some sort of resolutions, like with respect to the width and with respect to the height of the display, they have some sort of resolution. We'll be using those resolution to calculate the pixel per inch. But before that, let me tell you that the displays that you have some sort of pixels that you have already seen in the video, I guess. Like these are the pixels or small pixels that you see. So these are basically the coordinates with respect to x and y axis. So whenever we talk about displays, displays can be divided into two parts, like the y axis and the x axis. So this many axes that we have for any display, right? So if you want to display an image in a screen, so you will be positioning that with respect to the x and y axis of that particular display. For example, let us imagine that this is the laptop screen that you have, or the desktop screen or the monitor, whatever you say. This is the screen that you have. Okay, this is the screen or the LCD panel that you have. Okay, let us imagine that this is the desktop monitor. Okay, so this is the x-axis that you have and this is the y-axis. So the moment you start positioning an image, or the moment you start putting an image in the screen, the image will come with respect to the x and y axis coordinate, right? So with respect to the x and y axis, the coordinate will be placed and the particular icon or the particular image that you see will come up in the screen. Okay, so this is how it works. But what if we talk about the pixels or the number of pixels that we should have in a standard display? So how they are being calculated? Okay, so they are being calculated with the help of the resolution that we provide in that particular display. Okay, so here we'll be learning about the megapixels as well as the resolution with respect to the display. Okay, for example, you have a smartphone. Literally in a smartphone or any screen, you won't be able to see the pixels because the pixels that you have is literally very small, this many small. Okay, so here I have zoomed the pixels where you are able to see each and every squares, but in a smartphone you won't be able to see the pixels because those pixels are being placed in such a way. Here also I think still you have the capability to see the small dots, but literally you won't be able to see those pixels because those pixels are so tiny that you won't be able to see that which portion of the screen is having that, or which portion of the pixel is actually operating for that particular image. So you won't be able to see, you will be seeing that complete image, but instead of that, in the back end, so there are some sort of pixels which works. Okay, let us imagine that this is your screen or this is your smartphone screen that you have, I hope you are able to see. Okay, so this is the smartphone screen that you have, and the resolution of the smartphone screen is such that it is of, let's say, 1080 into 1920. 1080 into 1920. Okay, that means in the width we have 1080 and in the height we have 1920. So this is the resolution of the screen. Okay, so this is the width. So here we have 1080, that means 1080 number of pixels, and here we have 1920. Okay, here we have 1920. Okay, so if you see, then this becomes the width and this becomes the height. Now you know that whenever we measure the screen size, or whenever we measure the size of the size of the screen is being measured diagonally. Okay, please try to understand that the size of the screen is being measured diagonally. So if you want to measure the size of the screen, let us imagine this is an hypothetical situation. The size of the screen is to be as 5.5 inches. Okay, so from this point, if we calculate the size of the screen from this point to this point, okay, diagonally, then the display size of this particular screen becomes 5.5 inches. Okay, so the display size of the screen becomes 5.5 inches. And as I said, there are 1080 pixels in this width and there are total 1920 pixels in this particular region. Okay, so what is the total number of pixels that we have in an inch for the screen? Okay, so 1 inch में कितने pixels है वो कैसे calculate करेंगे? So if you go by the mathematical rules, then you will be able to see that this forms a triangle. Okay, this forms a triangle, and by using Pythagoras theorem, you will be able to get the number of pixels in this diagonal region, right? हमें पता चल गया कि विड्थ में कितने पिक्सल्स है, हमें पता ये भी चल गया कि हाइट में कितने पिक्सल्स है, as well as we know that the size of the screen is 5.5 inches, but we don't know the exact number of pixels in the diagonal axis or in this particular region. Okay, so this is basically the base, this is the height of the triangle, and in the hypotenuse we don't know how many pixels are there. Is that okay?
Yes, sir.
Yes, sir.
Okay, but yeah, great. So now what we'll do is we'll be applying Pythagoras theorem in order to get the number of pixels in this region. Okay, so this is how the mathematics comes into play. Okay, so we'll be using Pythagoras theorem and we'll be applying to get the number of pixels in this region. So let us try to understand it. If this portion is clear, if this graphical portion is clear, I would request each and every one of you to type GG in the chat box. Okay, great. Okay, so let us move ahead to this Excel sheet so that we can calculate the number of pixels in the diagonal axis. Okay, let us imagine, or let us take that in the width we have this many pixels. Okay, 1080, and in the height, or like, yes, in the height we have this many pixels. Okay, and we need to calculate the number of pixels in the diagonal region. Okay, so this is the problem statement. Okay, I hope you have understood the problem statements. The number of pixels in the width region, the number of pixels in the height region, and the number of pixels that we need to calculate in the diagonal region is not given. So we need to calculate that. So how can we calculate that? So that we can get the number of pixels per inch in a screen. Okay, so simply we can use the Pythagoras theorem. By applying Pythagoras theorem, what we need to do is we need to get the square of this as well as the square of height and width. We need to add that and perform the square root so that we can get the number of pixels in the diagonal region. Okay, so let us try to understand that. Let's say if we perform the square root, or if we perform the square of width, then in that case what we will get, let's say power of this comma 2. Okay, so we got the square of this, and for this case what we'll do is we'll simply use power of this comma 2. That means we are getting the square of this width and height. Okay, so in the next step what we'll do is we'll add so that we can get the square root finally. Okay, so let's add. So this is the sum of this squares. Okay, like the squares of W and H. So what we are doing is we are doing this. Let me show you. Okay, so diagonal square is equal to width square plus H square. So finally what we'll get, D is equal to square root of width square plus h square. So this is what we get. Okay, so yes, we got our sum. In the next step, what we'll do is we'll perform the square root. Okay, so let us try to perform the square root. So this is the portion, and in this portion we'll be calculating the square root. Okay, square root of this. So you can see we got our square root. Okay, but still we are left out with the number of pixels that we need to calculate for the screen. So this many pixels we have in the diagonal region. So we got our value. So the number of pixels that we have in this diagonal region is 2202. Okay, so in this region the number of pixels we have is 2202.9. Okay, let's say 9. Yes, 90. 2202.90. So this many pixels we have in the diagonal region. Okay, so up to this, if it is clear, please type Y in the chat box. Up to this, if it is clear, please type Y in the chat box. Okay, so the next step what we'll do is, in case if it is not clear, please don't hesitate to type N in the chat box. In case if you're finding any difficulties, please type N in the chat box. I will be more than happy. I'm saying it once again. Okay, great. It seems that the concept is clear up to this. So by applying Pythagoras theorem, we are able to get the number of pixels in the diagonal region. Okay, so what about the number of pixels per inch in the screen? So in each and every inches, how many pixels we have? So for that, what we'll do is we will divide the square root of this entire thing. Okay, the square root or the number of pixels that we have in the diagonal region with the display size. So as per as the hypothetical situation, the size of the display was 5.5 inches. So in the next step, what we'll do is we will directly divide the number of pixels that we got for the diagonal region with 5.5. Okay, so in the next step, what we'll do is we'll directly divide the number of pixels that we have for the square root region with 5.5. The value to be as 400, which is approximately to be taken as 401. So that means if we talk about PPI, then for this display with 1920 into for this display with 1080 into 1920, the number of pixels that we have per inches is 401. यानी कि एक इंच में 401 पिक्सल्स है. So can you imagine that how many pixels we have? कितने ज्यादा पिक्सल्स है? यानी कि एक इंच के साइज में हमारे पास 401 पिक्सल्स है. Okay, so this is the only reason that why you don't see the pixels. But if we zoom in, you are able to see these pixels. But just think of that in an inch, that if we place 401 pixels, it will be very difficult for us to get the pixels directly by human eye. So now let us try to understand the different type of resolutions that we have for displays. Okay, so if we talk about the resolutions that we have for displays is as follows. Okay, so if we talk about NHD, for NHD displays we have 640 pixels in the width region and 360 pixels in the height region. Okay, so if we talk about SVGA display, then this many pixels we have. For HD, please try to understand, whenever we talk about HD display, okay, for HD display we have this many pixels in the width and this many pixels in the height region. There is also a technology called HD plus. Okay, so this many pixels we have in the width region and this many pixels we have in the height region. So if we talk about full HD, so that the example which we took as of now, so in full HD display you have 1920 in the width region and 1080 in the height region. Okay, so it depends upon like how you take the display. So I took the display in this way, so that this is the reason why we got the number of pixels as 1080 in the width region. So if you just flip the display, in that case you will get that in the height region we have this and in the width region we have this. Okay, so it depends like how you orient the display. So in that way you will be taking the number of pixels in the width and height. Okay, so yes, this is the aspect ratio for each and every display. I hope the concept of the number of resolutions, the concept of number of resolution that we can have, as well as the number of pixels that is suitable for each and every display is clear. Like if you have a 5.5 inches display, in that case, this resolution is perfect. So this was all about the display technology, the pixel per inches, the mathematical way to calculate the number of pixels in each and every inches, like which formula to use and how to calculate, and what are the different type of display resolutions available. Okay, so this was all about the output device, specifically the display device. Okay.